everyone, welcome to this week's discussion of will today be the day that I finally burn my house down? Just kidding, maybe. Anyway, welcome to week 4, our interactive discussion in which we will be doing an elephant toothpaste lab. So I have today's lab set up. Don't know if you can see it. Readjust a little. There we go. So I have everything for today's lab. So just as kind of an introduction, so the elephant toothpaste lab is intended to be an example of an exothermic reaction. And so I think I mentioned this briefly in last week's discussion, but exothermic versus endothermic reactions. So endothermic reaction is where heat is absorbed and therefore things become cooler to the touch, versus an exothermic reaction where heat is released, and this is typically in the formation of bonds. Heat is released and so things become hotter to the touch, and so this is one of those examples where the overall reaction, more bonds are formed than broken, and so therefore the reaction is exothermic and becomes hotter to the touch. So with this elephant toothpaste experiment today, we will be using hydrogen peroxide, and I know that it says to use 10% hydrogen peroxide, and that is to get a more exothermic reaction. What I could actually get a hold of in a reasonable time frame was just household 3% hydrogen peroxide, so hopefully the reaction still works. It just might not be as exothermic or as large of a reaction as if I had used 10% hydrogen peroxide, which is fine as long as we still get the same concept. We have regular old Dawn dish soap. I have some generic, literally great value generic active yeast that I got from Walmart, and a bowl of, I know you can't really see it, but I can feel it, so a bowl of warm water to help activate the yeast. So in today's experiment, just as a premise, so hydrogen peroxide, which part of the reason why it is kept in a dark container is to keep it from decomposing. Hydrogen peroxide will naturally decompose into H2O and oxygen, which is O2. So we keep it in this dark enclosed container to keep it from decomposing. But naturally, once you let it out into open air and light, it'll start decomposing on its own. However, this is a fairly slow process. So what we will be doing today with the dry yeast, and you could also use potassium iodide, is we are going to use yeast as a catalyst to help speed up this reaction. And since it is speeding up this reaction process, it is creating a more exothermic reaction. And so the hydrogen peroxide will break down into H2O and O2, and then by adding Dawn dish soap to the reaction, the oxygen that gets released will get captured in the suspension made by the soap, and so that's where we get theoretically a bunch of bubbles slash foaming action that occurs. And again, if I had a higher concentration of hydrogen peroxide, then I would more likely get a stronger reaction. So hopefully with a low concentration, I won't make a ginormous mess or blow anything up. That's today's goal. And then just for funsies, to add color, we have some food coloring. I have blue and green because personally they're some of my favorite colors. So yeah, we will proceed with today's reaction and see how it goes. So I'm adding, honestly, no specific amount of hydrogen peroxide, just an amount. So hydrogen peroxide, we're gonna add some dish soap and our dry yeast in a separate container. Pew. honestly, because I don't know how much of this to add, I'm just gonna open up a second pack. I'm not gonna use the entire second package, but I'm just gonna open up a second package to add a little bit more yeast. Okay. And then we are going to put in our warm water. And honestly, you can kind of see some of the foaming action of the yeast itself in the water. And we're just going to give it a little mixy mix. And so what the dry yeast has in it is an enzyme known as catalase, which is our catalyst for this reaction. So there. Just a fun side fact while I'm mixing here. I feel like I should add a little more water. Okay, so we have our yeast, we have it mixed in warm water, and then again for funsies, we're just gonna add some food coloring into the container before we pour in the yeast with water. And for this experiment, I know I didn't show it, but I used some distilled water that I had left over from the last experiment. I don't know that it actually matters whether or not you use distilled water or tap water, but I figured it wouldn't hurt. So food coloring, and then yeast. Oh, okay, so yeah, I made more of a mess than I had intended, but I don't know if you can see. We have our foaming action going on here. But yeah, that is our elephant toothpaste experiment for this week. So obviously if I had used a higher concentration of hydrogen peroxide, I would have gotten a more exciting exothermic reaction. And if I touch the glass, I can feel the heat coming off of the glass from the reaction being exothermic. But we have our fun colored foam here now, and I made a mess. But nothing got blown up, so that concludes this week's Am I Going to Blow the House Up? The answer was no, but also concludes this week's discussion for elephant toothpaste. I hope everyone had fun and learned something, and I'll see you next week.